Hello dear friends, in this video I want to tell you about two methods for calculating the snow load on a greenhouse roof. In the first method we will use a snow load map of the Russian Federation, specifically the Leningrad region. In the second method we will calculate the snow load based on the density of the snow. We will start with the first method using the snow load map. According to the snow load map, we have 168 to 240 kilograms per square meter. I chose 240 kilograms and converted this to newtons. So, let's go to the load settings, enter, and specify the load that I converted from kilograms to newtons. We'll specify our roof and indicate the direction. Set the direction and click OK. I have already created the fixed geometry, these points. Now let's apply the material. For my frame, I'll set carbon steel, apply, close. Next, in my cut sheet, I will find my roof and apply the PC high viscosity polycarbonate material to it. Apply, close, hide everything, and I click, it creates the mesh. And after that, the calculation will take place. The calculation has been completed. And now, in order to see the result at true scale, we'll switch to displacement with a double click and change some parameters in displacement. Here, right click on definition. There's a deformed shape parameter here. Right now it's set to automatic, we'll switch it to true scale. Click OK. And you can see that our greenhouse is almost completely undistorted. There is a table here from which we can take the result of the maximum deformation, transfer it to our site, and find out the value we obtained. My roof sank by 9 millimeters, 9 and 8/10 of a millimeter. Well, approximately 10 millimeters. That's not much, and it won't destroy the structure. Now I'll show you a second option, where we calculate the snow load ourselves. Let's go back to the model dialog. Now we'll create an element for the snow load. Select this surface, sketch. Ctrl 8. Take the arc. We'll get an arc. We'll have 1/2 meter of snow. From this point, draw a line to this point and do the same on the other side. Now I'm creating an element that will represent the snow load on the greenhouse roof. Just like that. Simply make both lines vertical. After that, make them tangent. Make the other line tangent as well. And set the thickness to 1/2 meter. I chose 1/2 meter based on my own observations, since that's about how much snow usually piles up if you don't clear it. If you have a different experience, calculate it yourself for your own thickness 500 millimeters. I made the snow this shape because it slides down the sides, so it ends up looking like this. Here, we convert the geometry, make an offset of 10 millimeters. Yes, here is the direction. Let's turn off the chain. Turn off reverse as well. Okay. And cut off the excess. Trim units. Cut it off. And we cut it off on the other side as well. Okay. Next, we extrude this. First, the bottom layer, this will be our layer of ice. And here is the direction up to the surface. We pull it out along the entire length of the greenhouse, right here. Merge result should be disabled. Enter. Let's wait while it checks the connection. And then we display this sketch again. Again, we extrude. We select this contour up to this surface. Result is enabled. Enter. Again, we have these points. It created them. Now let's hide everything except our layers. Select these two layers with the mouse button and isolate them. Now we'll assign material to them and hide the sketch. I need to assign material. We'll create a custom material and edit material. And here we'll create a custom material, a second custom material. And now to create a new library where we'll add our materials, right click on the custom material and select new category here. A new category appears. I've already created one and named it snow. Delete. Right click on our category and select delete here. Let's make snow. I've already created it and right click and select new material. I'll name it wet snow. Wet snow. In mass density, we'll set its density value. My parameter ranges from 400 to 830. Wet snow is firm. That's the category of snow. I'll set the density to about 700. 700. Play. Next, I'll create another new material. I'll write ice. Ice. And I'll set its density to 920. Click, play, and then close. In order for the material not to be applied to our entire structure, we'll assign it through the CAD list. Let's find our element in the CAD list, the top part of which should have the snow material. Right click on material, edit material, and I'll set it to wet snow. Apply. Let's wait a bit. Close. Everything has been set to wet snow. And for our ice crown, we'll add the ice material. Excellent. Here it will be polished automatically. So let's select these two elements. Isolate. Now we've isolated our two objects. Next, go to Evaluate Mass Properties. Clear everything here. Select this element, and this element shows us 4,277 kilograms. Highlight this mass. Copy it and close. Exit isolate. We don't need these elements anymore. Hide them. Go to our static. After that, we delete our pressure. And we ultimately create a substantial force on our roof. As a result, select the direction. And now we convert the pressure to newtons and input this value in newtons here. This is the value we got from the snow load, reverse direction, and okay. But before we run our simulation from the cut lists, we disable our snow and our ice crust. Exclude from analysis. And do the same thing here. Everything is disabled. After that, click and wait. In SolidWorks, there are 3 types of deformation: force, pressure, and gravity. But with gravity, I ended up with incorrect deformation A supports deformed instead of the roof. I'll figure this out and record a separate video about loads. So, here is our deformation 9 millimeters. The deformation turned out to be almost the same as with the snow load map. And the last thing I wanted to cover in this lesson is how to remove the exponential number notation. Let's go to displacement by double-clicking on it. Here, go to Chart Options, and under the thickness of our color bar, select Floating instead of Scientifics. Then it will display all the numbers, plus 3 decimal places after them. I'll choose General, and now all our values will be shown without exponential notation. In this lesson, we learned how to disable exponential numbers and performed 2 calculations for snow loads. This was Alexi Tifio video. Subscribe to our channel and give this video a like. Bye bye everyone.